I'm going to do some tutorials on how to deal with integrals of this form. And this is the form where we need to split into partial fractions. We can't integrate this the way it looks at the moment, but it is of the form of a partial fraction. So what we're going to do is we're going to deal with it and change the way it looks first so that it can become something that we are able to integrate. So a bit of a recap on partial fractions, and what we do for these are we say that we know that this has come from adding two fractions together whose denominators were originally something over x plus 1 and something over x take 2. If we add these two fractions together, we would need to make a common denominator and then add the numerators, and they're telling us that that would give us x take 5 in this case. So we don't know what's going to be on the top at the moment, so we're going to write down a plus b, and then what we're going to do is multiply, sorry, this should be an identity, we're going to multiply by this denominator on the left hand side and simplify what we've got. So when we multiply by the denominator, we're just going to have x minus 5 on the right hand side, on the left hand side. When we multiply this by the denominator, the x plus 1 terms are going to cancel and we'll be left with a times x take 2. If you're not sure why that is, that's because I'm timesing by x plus 1, x take 2, and that would cancel those terms out. Same for the b term. If I times by x plus 1 times x take 2, then the x take 2 terms will cancel and we would be left with b lots of x plus 1. Now, because this is an identity, that means it's true for all values of x. So we can choose a value of x to look at what happens to the left hand side and the right hand side, because that's going to need to be equal. So if we, for example, let x equal 2, and I've chosen x equals 2 because this term will disappear because the bracket will be worth 0. That's going to allow us to work out the value of b. So when x is equal to 2, the left hand side will be equal to negative 3, and the right hand side will be equal to b lots of 2 plus 1, so 3. And if you solve that little equation, we'll find that b has to be equal to negative 1. If we do a similar thing for the b term to get rid of b, and in this case we're going to let x equal negative 1, that will give us negative 6 on the left hand side. The b term will disappear and we'll just have a lots of negative 1 take away 2 more, so negative 3, which means that a must have been 2. So we now know that x minus 5 over x, what was it, x take 2, x plus 1 x take 2 is exactly the same as 2 over x plus 1, and it was a minus 1, so I'm going to write that as a takeaway. Takeaway 1 over x take 2. They are the same, they're identical. Now, we can't integrate this, which is what the question's asked for, but we can integrate these two terms here. So when we're being asked to answer this question, the integration question, we're not going to integrate it the way it looks. We're now going to integrate 2 over x plus 1 minus 1 over x take 2. And that can be integrated. This is one of our rules for integration. This is a linear expression here to the power of 1 on the denominator. That's going to be one of our log questions. You will often get log integrals with partial fractions. Not always, but quite often. So integrating this, we're going to pretend this is an x and integrate, and that would be 2 natural log the modulus of the denominator, which in this case is x plus 1, and we'd need to divide by the coefficient of x here, but that's just 1 in this case, so that is just the integral. For the second term we've got a minus, and this again is the same form, so it's going to be the natural log of x minus 2 over 1, don't need to write that down, plus c. So that's the integral. Some people like to, or sometimes the exam questions ask for this as one term. And in that case, we'd need to go a little bit further. We'd need to bring the 2 up as a power. Notice I'm removing the modulus signs because if we square something, it will always be positive anyway. And then we can use our rule for subtracting 2 logs, which would become a divide. So I'm going to have to reintroduce the modulus sign in case the bottom is negative. So that would be x plus 1 squared over x take 2. Now I wouldn't suggest you do those last couple of steps unless it's specified in the question. If it just said find the integral, I would stop here. If it was a definite integral, so if there were numbers on the bounds of the integral, again I wouldn't bother doing this. You can do it would save a little bit of time when you do come to do the substitutions, because you'll only have 2 terms to deal with rather than 4. But it's personal preference. If you like doing these last couple of steps, go for it. But it's up to you. So the next question I've got is a slightly more complicated question, in that we have a repeated factor here. We've got a repeated bracket, and hopefully you remember that when we've got partial fractions of that form, we will have 3 terms to deal with. So it's going to be something over the first bracket, something over the second bracket without the square, and something over the second bracket with the square. That could have been what was added together to give this. Sometimes this term becomes 0 because we might not actually have had that term, but we're kind of saying this is worst case scenario. I could have had these different fractions to begin with that added together to give this. So same procedure as before. To start with, we're going to multiply by this denominator. When I multiply by this denominator this time, the 2x plus 1 term will cancel, and for the first term we'll have x minus 2 all squared. When I multiply this by the denominator, one of the x minus 2 terms will cancel, and so we'll have the 2x plus 1 term, and we'll have one lot of x minus 2. And for the c term, the x minus 2 squareds will cancel, and we'll just have 2x plus 1. Again, we're now going to choose sensible values of x that will eliminate or make some of these terms disappear. The first one is going to be x equals 2. And if you substitute that into here, we're going to have 8 lots of 4 minus 38 plus 1. I'll work that out in a second. Is going to be equal to, this term's going to disappear, this term's going to disappear. This is going to allow us to work out c. So we're going to have c lots of 5. So 32 take away 32 take away 38 is negative 6. Add 1 is negative 5. So c must be negative 1. So there's 1 done. I'm going to let x equal minus a half now to get that second bracket to disappear. So we're going to have 8 lots of a quarter minus 19 over 2, plus 19 over 2 plus 1. I'll work that out again in a minute. Here we're going to have a lots of minus 5 over 2 squared. So that's going to be 2 plus 19 over 2 plus 1. I could pick a calculator up at this moment, but I haven't got one with me. 25a over 4. That's the same as 3 plus 19 over 2. is equal to 25a over 4. I'm going to times everything by 4, so that's going to be 12 plus 38 is 50 equals 25a, so a is equal to 2. Okay, now the problem we have now is that we've chosen the two values of x that will make each bracket be worth 0, and we've still got to work out b, because with b both times the bracket equaled 0. In order to find b, we now choose one last sensible value for x that will simplify our expression and see what we've got left to deal with. 0 is a good value to choose, 1 is a good value to choose if we've not chosen that already. Something small and easy to work with. So I'm going to let x equal 0. On the left hand side that will give me 1. On the right hand side that will give me a lots, but we know what a is. A is 2. So 2 lots of negative 2 squared, so that's 4. B lots of 1 when x is 0, 0 plus 1 is 1, times by negative 2. Add c lots, but c is minus 1, so take away 1 lot of 1. When x is 0, we have 1 here. So that gives us 1 is equal to 8 minus 2b minus 1, which is negative 6 is equal to negative 2b, which means that b is equal to 3. So those are our three values for a, b and c, which means that we can say that 8x squared minus 19x plus 1 over x 2x plus 1 times x minus 2 squared is the same as 2 over 2x plus 1 plus 3 over x take 2 take away 1 over x take 2 squared. To check that I've got that right. Yeah, I've got the right order and I've got my a, b and c right. Okay, so again, if we go back to the question now, we were being asked to integrate this. We're not going to integrate that. We're going to integrate what we've turned it into. So we're going to integrate these three terms here. Now, the first two terms will give us logs. We've got the ax plus b form on the bottom here, and it's raised to the power of 1. This term is not of that form. Yes, this is linear, but it's being raised to the power of 2. So that is not going to become a log. That is going to be our polynomial form, where we add 1 to the power, divide by the new power, and divide by this a term as well. Okay, so just be careful of these partial fractions questions that have a repeated factor. They're the ones that aren't going to give a log. So if we now integrate each term, we're going to have 2 from this times the natural log of 2x plus 1. Divide by the coefficient of x will be dividing by 2. For the second term, I'll cancel those out in a second. For the second term, it's going to be 3 lots of the natural log of x take 2 divided by the coefficient of x, which here is a 1, so there's nothing going to happen there. And I need to turn this into a negative power so that I can apply my power rule, which is add 1 to the power, divide by the new power, and divide by the coefficient of x, but that's a 1, so I don't need to deal with that. Don't forget your plus c. So they've all been integrated now, we just need to tidy this up. The 2's are going to cancel, so that's going to be the natural log of 2x plus 1 plus 3 lots of the natural log of x minus 2. These 1's are going to cancel, so we're going to have plus x minus 2 to the power of minus 1 plus c, which we could write as 1 over x take 2. You could do what I did on the previous question, bring this up as a power, and then in this case they're being added, so this is going to be a times. If you want to bring this together as one log, it will be a times multiplying these two terms together. So that's going to be 2x plus 1 times x minus 2 cubed. Don't forget your mod signs. So again, you don't have to write this unless it specifies, but just in case it does, that's why I've done that extra step. Normally you can just leave your answer like this. Okay, for the third example that I've got, we can't do partial fractions on this straight away, and the reason we can't is because the powers here are equal. This is known as a top-heavy fraction. When the degree of the numerator is of equal or higher power than the denominator, we can't do partial fractions. What we need to do here is reduce the power on the top down so that it is in partial fractions form. And to do that, we need to do polynomial division first. This won't take very long for this one, but that's what you need to do for this type of question when the powers are of equal or this is a higher power. So for example, if this had been a cubed term, we'd need to do a bit of work on it first before we can do partial fractions. So we're going to start off by dividing the 9x squared minus 3x plus 2 by 9x squared take 4. So if you remember how we do this, we ask how many times does 9x squared multiply into 9x squared, and the answer is just 1. And then we say what's one lot of 9x squared, which is 9x squared, so that's going to go here. And we're going to subtract one lot of 4. Notice I've just put that under the right value, the right unit. So we then subtract this, which will be 0, minus 3x minus nothing is minus 3x, and 2 minus 4 is 6. So that's finished now, that's done. We finished the division because this power is now bigger than this power here. So that tells us that the quotient is the number on the top here, 1, and the remainder is negative 3x plus 6. Okay, the next thing we can do then is rewrite 9x squared minus 3x plus 2, so the original question, divided by 9x squared take 4 as the quotient, which was 1, plus the remainder over this 9x squared take 4. So they're equivalent. What that means now is that this is starting to be ready to be integrated. Notice we can integrate the 1, and what we now have here is a power of lower order than this one. This is still not ready to be integrated because we can't integrate this. But what we can do is split this into partial fractions. So the next step is to now change the minus 3x plus 6 over 9x squared take 4 into partial fractions. Now, if you look at the bottom, that doesn't look like partial fractions in terms of the questions we've seen on the examples I've used so far, but this does factorise into 2 brackets. That is a difference of 2 squares, and sometimes we will have to spot that the denominator factorises and factorise it before we can start the partial fractions process. But it's a nice easy difference of 2 squares, so that's 3x plus 2 and 3x minus 2, which we can now say will be able to be split into something over 3x plus 2 and something over 3x minus 2. So next job is to work out what those values a and b are. And to do that, we are going to do what we've done on the other examples. We're going to multiply by the denominator. The 3x plus 2's will cancel, and we'll have a being times by 3x minus 2. And for b, it'll be the other one, 3x plus 2. And then we choose sensible values for x to help us find a and b. I'm going to have to choose for this one 2 over 3. That's what will make this bracket worth 0. So when x is equal to 2 over 3, we're going to have minus 3 times 2 over 3 plus 6 is equal to b lots of 3 times 2 over 3 plus 2. The 3's cancel here, so that's minus 2 plus 6, which is 4, is equal to b lots. Again, the 3's cancel here. That's 4 as well. So b is 1. And if we let x equal negative 2 over 3, that will allow us to find a. We'll have minus 3 times minus 2 over 3 plus 6 is equal to a lots of 3 times minus 2 over 3, take 2. That's, again, the 3's will cancel, so that's that's going to be plus 2 plus 6, which is 8, is equal to a lots of the 3's cancel here. This is going to be negative 4. So a is negative 2. Which means that if we remember what we had earlier, this minus 3x plus 6 is equal to minus 2 over 3x plus 2 plus 2 over 3x minus 2. So if I'm just going to take this and copy that, bring that down. Where's that gone? Okay, so we've got now then that this is equal to 1 minus 2 over 3x plus 2 plus 2 over 3x minus 2. So that's my a and my b value being substituted in for here and here. We had the a over 3x plus 2 and b over 3x minus 2. Now, if you go back to the original question, we were being asked to integrate this. And we said we couldn't integrate this. We couldn't even integrate this, but if you look now, we can integrate what we have here. So the final step is to now integrate each of these terms. The 1 will integrate to an x. This is another log because there's no square term here, but this is a linear expression. So that's going to be minus 2 natural log of 3x plus 2 divided by the coefficient of x, which is going to be 3, plus 2 times the natural log of 3x minus 2, again over the coefficient of the x, which is a 3, plus c. And I would leave my answer like that, but if they asked for this as a single log, we'd be able to say that that is x plus 2/3 of, I'm going to write this one first, natural log of 3x minus 2 minus the natural log of 3x plus 2. Notice I've taken the 2/3 out here, and then we can write this as a single log. So that is going to give us x plus 2/3 times the natural log of 3x minus 2 over 3x plus 2 plus c.